Over 80% of data online on the web is what we call unstructured data. So in this course, I'm going to show you exactly what is unstructured data and why is it that you need to pre-process this unstructured data into structured data so that the large language models are able to digest this data. It is an important skill or tool to understand, to learn, so that you are able to digest data, or at least you are able to create RAG systems that are able to digest that data, this unstructured data. That way the large language models are able to work efficiently and give you the results that you want from that data. And so it's an important step when you're building your RAG system, retrieval augmented generation. That's what we're going to be looking into in this mini course, and I hope you are as excited as I am. And let's go ahead and get started. So let's talk about development environment setup. These are the things that you need to have set up in order for us to keep going in this course. So first of all, we need to have Python set up, and need to have VS Code or any code editor that you may prefer. And also make sure that we have the OpenAI account and an OpenAI API key. And also we will need to have the Unstructured framework account and API key. So the great thing about the Unstructured framework is that they allow us to have this free API endpoint for the first 1,000 document processing, or pages, I should say. Shouldn't say documents, it should say pages. They count in pages. So it should be more than enough for us in this course. And anything be above that, then you'll have to pay. And I think is $1 for 1,000 pages that you process, and $10 for 10,000. I think that's the pricing that I have. But I'll show you all of that, how to set up everything so that you are ready for this course. Now, one thing, of course, I will have to let you know about OpenAI API account, even though in this course we are going to use that very minimally, I should say, is that you will obviously need the API key to be able to use OpenAI services. And there may be some costs associated with using the API, even though, as I said, it's going to be very, very minimal. I just want to be transparent so you know that may be some costs associated with you using the OpenAI API. So now we're going to dive in and look into data pre-processing for large language models. So we're going to go through a lot of things here. We're going to talk about unstructured data, of course, the content extraction from unstructured data, the whole process, the why content extraction matters and how it all works, the intricacies and everything, and of course the key concepts. The truth of the matter is 80% of data online is actually unstructured. But exactly what does that mean, unstructured data? So unstructured data is essentially all the information that does not conform to structured information, which means information that does not have a predefined data model. When you hear about unstructured data, we're talking about information that doesn't have a predefined data model or isn't organized in a preset manner, unlike structured data, which would be a good example, would be databases or spreadsheets. So unstructured data can include a variety of content, and here are some of them. So we could have textual data, so this will include emails, documents, social media posts, and so forth. And we'll have multimedia content, so this includes images, videos, audio files, and so on. But then we have what we call complex documents. So these complex documents comprise of PDFs, PowerPoint presentations, web pages in the form of HTML, and also scanned forms. So these are what we would call the unstructured data in different categories. Now we can look at a diagram here so we can have a visual on how the context between unstructured data and LLMs. So for large language models, unstructured data is what we call the raw input that the models must process to generate what we call meaningful outputs. But the problem here, because this data is not really, it's not structured, it's not organized, it requires significant pre-processing to make it usable. So the model the large language model in this case needs to understand and convert this data into a structured format it can work with, which involves extracting, cleaning, and organizing the information in a way that preserves, this is very important, preserves its meaning and context. So let's give it a good example here. Consider a PDF document that contains a mix of text, images, and tables. Now, to make this data useful for an LLM, each one of these components needs to be identified, extracted, and then converted into a format that the large language model can process. In this case, it would be plain text for text, sections, or structured JSON for tables, or metadata for images. This is what LLMs actually understand. And of course, as you can imagine, there are some challenges with unstructured data. And one of the main challenge is that of the diversity, which means data comes in many forms and formats. So that is a problem because the idea is to have some sort of a unified, normalized, standardized format that the large language model can consume and has all the pieces, all the metadata it needs to understand the context and the meaning of that data. And of course, complexity is another problem of unstructured data because often includes a mix of content types, for instance, text, images, and then we have tables and so forth. So those are the challenges, some of the challenges of having to deal with unstructured data. So this takes us to the why is data processing hard? Now, you may think it's really easy to process data, right? You can write scripts and do all sort of things. But there are some problems that come with pre-processing data. The first one is that we, again, have different document types. For instance, we could have visual types versus markdown. That's another example. So all of these have what we call unique cues for identifying elements within those documents, which makes it consistent processing very difficult, because you can imagine for a markdown file, the cues are different than those cues for HTML page or a PDF file. And of course, we also this need for standardizing everything. So to effectively process content across these vast different document types, standardization to make things standardized is very necessary so that we can maintain this uniformity. And also we have this extraction variability because, as we know, different formats like forms versus journal articles, for instance, these require distinct extraction methods due to their structural differences. And also, it's nice to have metadata extracted from these documents, but extracting relevant metadata often demands an in-depth understanding of that document structure, which adds more complexity to the pre-processing process. And so these are the challenges that come with pre-processing, which is why data pre-processing is hard. So now that we understand why data pre-processing is hard and why we need data pre-processing, let's continue here in the context, of course, of large language models. So once we gone through that process of taking the unstructured data as we saw previously, so we get to the point where we have the structured data. So this is the continuation where we had before. So now we have the structured data. And so what will happen now is that we take all of the mix of text, as we saw before, images and tables, and then we make this data useful for the large language model because we extract, for instance, the text section, convert that, we extract the image metadata, we extract the structured JSON from the table. So we are now continuing the pipeline downstream of the extraction, I should say. So this content here is what the model likes. This is what the model can actually process. And that is indeed what is passed along to the large language model. Because now we have this unified, normalized content that is easy for the large language model to infer from it the information it needs to give us the correct results. Now, this pre-processing is crucial. Why? Because the quality and structure of the input data directly impact the effectiveness and accuracy of the large language model outputs. This is why we are even talking about this, because large language models need to have a very clean, contextually aware piece or corpus of documents that will be feeding itself so that it gives us the correct, accurate output. It's very important, because if we feed our large language model very low quality information or data, corpus in this case, input, then obviously the output is not going to be that great. So that is the reason why we must go through this process of sort of extracting the most important information needed and normalizing that content so that we can feed a very clean, high quality structure of the input that is directly passed through the large language model, which will impact how effective and accurate the large language model outputs are. Well, why it matters, what we're talking about here is the content extraction from unstructured data. All relevant data in this case will be captured, so nothing's going to be lost. So extracting content properly ensures that all relevant data is captured and nothing important is lost in translation. So this again is particularly important when working with large language models, because they rely again on very high quality input data so that they can generate accurate outputs. All right, so now we know why it matters. In this case, why content extraction from unstructured data is important for large language models. Now, of course, there are some challenges with unstructured data. So number one, we've looked into this before, but like I said, there's many forms and formats available of different kinds of formats of data. PDFs, CSV, we have MD, we have PowerPoint, we have documents, we have so many different kinds. Okay. And so also the complexity, as we've seen. So we have this mixture of content types. For instance, we have text in one hand, and then we have images, and we have many different kinds of content types. And also, most importantly, we also have a volume of data. We have a lot of data out there, large amounts of data, which manual processing can be really tedious, and it's frankly impractical. So these are some of the challenges with unstructured data. Now let's go ahead and look at content extraction from unstructured data and see how it works. Well, essentially, we have two parts. We have the first part, which is what we call the text extraction. So these are really taken care of by tools that can extract text from various document types. But they need to handle, of course, complex elements like tables and images. Okay. And then we have the second part, which is the partitioning side of things. So what happens here is that these documents are chopped down or broken down into smaller atomic elements, as we call them. In this case would be paragraphs, sections, and so forth, headers, footers, right? So these atomic elements, these are the ones that can be processed individually by the large language model. Let's look at all of this process in more of a visual way. So essentially we have all of our unstructured data, the documents here, as you see. So we pass them through this text extraction. So essentially we break it down into sections and so forth. And then we actually go further to get to the part where we're going to partition certain parts. So now from these big documents that has different parts, we can extract, break down those documents or those sections in this case into atomic elements. So we can have a paragraph, a section, and so forth. Now, usually what happens is we actually transform all of this as when we normalize this data, this information, we transform all of that into JSON because it's just easier to use JSON, as you will see. So once the context is extracted, next step is the cleaning phase. So in this case, we're going to go ahead and clean the data and remove irrelevant or strange information that is not needed, such as headers, footers, or watermarks that could, in this case, interfere with the large language model processing. So we'll remove all of that, clean everything up, and we have that clean data, which in this case is in the JSON format because it's just easier to deal with. So this is what we call the normalized content, which is in this case now consistent formatting and so forth. So if you look from the left hand side from where we started to the right hand side, it's totally different. So now we have a normalized, a standardized format that we can pass through a large language model easily without having to deal with anything else, because now we have a structured format, a structured data. So the idea here is that it doesn't matter where we start with, right? At the end, we're going to have a normalized content, right? Which is going to be consistent, keyword consistent format across different sources. Okay, so we're going to continue learning the process of pre-processing, and no pun intended here, for unstructured data for large language models applications. So now we're going to go through the phase where we need to be chunking things. So once we have these documents and everything, they have to go through another process here called chunking. So what does that involve? Well, chunking involves breaking down. I'm going to show you here. So we have the documents. So we got the process of, first of all, the naive chunking. So just going through the first process, just a simple breaking down of each one of these chunks, right? And then we go through the other process of what we call smart chunking of those previous chunks. So chunking involves the process of breaking down the cleaned and normalized data into even smaller pieces, which can be fed into the large language model. There are two main approaches. So we have what we call naive chunking and the smart chunking. So smart chunking, what it does is it preserves the contextual relevance between different parts of the document, which is, again, as you know, is crucial for maintaining meaning and coherence in large language model outputs, which is exactly what we need. Naive chunking, on the other hand, may occasionally break context and lead to fragmented understanding. So obviously you would want to have a smart chunk so that we have that preservation of what we really want, the contextual relevance between different parts of the document. So at some point, this data needs to be structured. So we're going to go through the process of structuring that data. So the idea is that we go through the process and we do the smart chunk, in this case, just for section 1, just an example. And that has to be restructured or structured into a format. In this case, JSON format is just easier. And the reason why we want this is because large language models usually like or understand or prefer more of this hierarchical and relational aspect of content, right? Prefer this better than any other thing. The reason why, again, is because now we have this more accurate and contextually aware outputs. Keep in mind, all that we are doing here when we go through this process of extracting information from unstructured data to structured, more standardized and normalized data, the whole process here is for the validity, the contextuality, and meaning preservation that we need to be able to feed that into the large language model so it can process better and the outputs will be also better. Because it makes sense. Having a structured data allows the large language model to understand these hierarchical and relational aspects of the content. Because now if you look, we have this JSON object, we have section 1, we have content, section 2, also content, and then we have metadata, a lot of information about the documents section and so forth, and more information. So now we have this hierarchy of data which the large language models like, and it's easier for it to digest and extract more meaning and context from that structure. So it's important to note here is that once we have this structure and the way things are structured now, the sanitized, the clean, the structured data, right? Normalized that I should say in JSON format, you notice again that we not only have the JSON structuring, which is the data in way that, which is how the data is organized into JSON format, which is also great because it's both human readable and machine friendly, but also we can include, or there is this other inclusion here of metadata. This is really important because we can add more information, additional information, for example, section titles, dates, and other things we want to add, and include that, which again will enrich the data itself before we pass that through the large language model. And so all of these pieces of the flow that we're looking at, we're trying to start again from unstructured data to end up with something that is structured so that the large language model can process easily. And so it would be nice to have some sort of a workflow that will allow us to easily do all of this, because we could do all of this processing manually, but it would be nice to have some sort of tool that allows us to do all of that. So the idea is that we can orchestrate everything, this whole flow that can handle all this complexity of processing large volumes of unstructured data, right? Because this involves a lot of things, connectors, automation tools, and scaling strategy to make sure that the data is processed efficiently. Okay, so you can see here we have raw data sources, go through source connector, so it knows, okay, this is raw data CSV file, this is a PDF file, this is a document file, etc., and goes through the process. It sends downstream extraction, go through the process of extracting information from these documents, cleaning, chunking, and structuring, as you saw here. So the idea is to go through this processing pipeline. And then, of course, the destination connector. This is what will allow us to know, okay, how do we then connect this to the large language model so that it can ingest. Source connectors, in this case, these are just tools that fetch raw data from various sources. Makes sense. The destination connectors, these also are tools that write the processed data to storage or directly into the large language model, as we will see in this course. Okay, so the automation of all this thing is a way of scheduling and scaling the whole processing tasks to handle large data sets. Because if you think about it, most organizations have all these different data formats, documents that are saved everywhere. Okay, so to be able to have a workflow that is set up so that all of this processing workflow has some sort of orchestration to make it easier to pre-process raw data, in this case unstructured data, into a format that can be used by the large language model. And there is such a solution in a sense, which is what I'm going to look at. The solution is what we call the unstructured framework. So the unstructured framework, what it does is streamlines the pre-processing of unstructured data, making it easier to feed into the large language models for various reasons. So you can use that then for RAG systems that you can build or any other AI applications. Okay, so we're going to start looking at the unstructured framework that will make it easier, give us all the tools that we need to go from A, in this case unstructured data, to B, sanitized, clean, normalized, standardized data, and ways to connect to, in this case, a large language model so that they can continue downstream processing. So in the last lecture, we talked about unstructured framework. Just the beginning, we know that allows us to streamline this whole process or pre-processing of unstructured data into the final downstream normalized, clean, and ready to use data, right? In this case, data, in this case, content for the large language models. But how does it work? Well, it's very simple. It goes through the content extraction and then goes through the partitioning and structuring, as we talked about here, right? And then it goes through the cleaning and normalization of that data content, and then metadata enrichment, adding more metadata, more information to this normalized data, right? In this case, in form of JSON. So additional information that is attached to the data, which improves its utility for large language models. So when we talk about cleaning and normalization, so the framework, what it does, it goes ahead and removes noise. In this case, just removes things that aren't that necessary for the large language model, such as headers, footers, and so forth, and make sure that it standardizes the data. Very important. And the partitioning part of things, as we saw, and structuring, this is where the extraction of the content is divided. This is where the extracted content is divided into sections and converted into structured format, typically JSON, as you saw. And the content extraction, which is the first part we've seen here, is the part where the framework is able to identify and extract text, images, tables, and other elements from a document. Okay, so these are the four main functions that are extremely important in the data preprocessing workflow, which is all part of the unstructured framework. So how does this really work? Well, first of all, we have our raw data sources, and they go through the first phase, content extraction. So it extracts text, images, tables, and so forth. And then the partitioning and structuring part of things, in this case of the text, images, and tables, and so forth, and the cleaning and normalization as we saw, and then the metadata enrichment, and the final result is the structured data, which in this case is going to be in JSON format. Now, could be different format, but JSON format seems to be portable and easy to read and so forth. Unstructured is really good at handling multiple various document types like PDFs, documents, and HTML and MD files, PowerPoint, and so forth. So it's all set up. All you have to do is import a namespace, a library, and then you're ready to go. And also it's able to divide content. This is the smart chunking part we know, because it's good for preserving the contextual meaning of those pieces of data. So it's able to divide this content into meaningful sections, and again, preserving that context. It can be also integrated, it's very integratable, I should say, into large-scale pre-processing pipelines. Because imagine that you have your organization with millions and millions of files, different formats, and so forth. It's easy to use with Unstructured Framework because it has all the pillars to allow you to automate everything. So the best way to illustrate everything, I'm going to show you this data pre-processing workflow with Unstructured Framework. So this image here illustrates something that may happen, something is very common in big organizations. So we have, for instance, different departments, finance, ops, HR, legal, and many, many others. So all of these have many kinds of documents: PDF, TAR, HTML, SQL, email, zip files, XSL, XLS, CSV, you name it, right? But most importantly, then, we pass all that information, right, through the Unstructured Framework. And so the Unstructured Framework has this ability to take all these data sources, various formats, right, and platforms in this case, across different business domains, okay, is able to ingest and pre-process all that information and convert that into suitable format. And so this whole thing here is that also we could save all that information into a vector database. I'm just going through everything here so you can see the final thing that really happens. And also this data is stored, or can be stored, in a vector database where it can be accessed and queried using embeddings. And then we have this embedding endpoint. This is where it generates embeddings for the data, which are these numeric representations used for similarity search and large language model queries. And then we have this layer of what we call the LLM programming framework. So in this case, the large language models use these embeddings for various tasks, with agents facilitating interaction between the large language model and the vector database. So there is this communication. And we have the endpoint, the LLM endpoint. So this is the processed data which is utilized by the large language model, enabling it to perform functions like natural language queries, summarizations, or generating responses. Okay? And then we have the side of the large language application itself. So this is the final step, the final downstream area where the large language model's outputs, that's where these outputs are used, which provides actionable insights or generating content based on the processed data. So looking at this diagram here, at this workflow, this illustrates essentially how you can go from raw, unstructured data that is actually transformed into structured format that can be efficiently used by large language models in various applications. So, my friends, you've learned essentially the most important fundamentals when it comes to transforming unstructured data to structured data so that large language models can actually work properly, because now they have this sanitized documents, data, pieces of data that are standardized and are also enhanced with more metadata, which is the best recipe to feed into your large language models, because now your large language models have better context and better meaning of those documents, which means they can actually do what large language models do best: process it and return good outputs, good results. So we did a lot of theory. We talked about a lot of concepts about unstructured data, how unstructured data works, what the tools that we need, the whole process workflow to go from unstructured data to actual sanitized and clean, standardized format data, in this case in form of JSON. So you understand that the tool that we're going to be using in this course is going to be Unstructured Framework, because that's all it does. Obviously, we could write our own code to do all of this. Of course, it's possible, but there are tools. It's always important to use tools, proven tools, to facilitate our work. And that's what we're going to start doing in the next videos, to look into the Unstructured Framework to start cleaning some data and pass it downstream for more preprocessing, and ultimately feed that data to a large language model so we get the results that we want. All right, so first let's go to docs.unstructured.io/welcome, as you see here. And this is where we're going to create an account so we can go ahead and create an API key, a free API key. Now, Unstructured is a newer company and framework, and so there's a lot of things that are changing over time. So make sure that you know things may be different by the time you watch this video, but the idea should be the same. Now, there's a lot of services, a lot of things that you can do here, of course, and from paid or pay as you go and so forth. But we are interested in a free service at this point. So let's scroll all the way down where it says sign up. All the way down, we want a different service, quick start unstructured API service. So we're going to use the unstructured Python SDK. Okay. So the first thing we need to do, of course, is to create an API key. For that, we'll have to have Python installed and on our local machine and all of that. So let's go ahead and sign up. So all we'll do, right click and go ahead, and this will open it in a new browser. Okay, so go ahead and sign up. So add your credentials here and everything. Okay, once you've done that, it should give you success. Check your email for your API key. And so at this point, the email I've used, go ahead and check that email to get your API key. So once you have your API key, make sure to add that into a project or just save it for next time. But I have this project here. Create a .env file and add your unstructured API key and other API keys, something like this. All right, so keep in mind that this is actually a free tier and they have a cap here. So usage is capped at 1,000 pages per month, which should be more than enough for what we're trying to do here. All right, so the next thing here, you see that we have the free edition, the API URL. So this is what we also need. So I'm going to copy this and paste it all in such like that. Okay, so at this point you should have the Open API key, the Unstructured API key, as well as this Unstructured API URL, which you can get from our docs Unstructured.io welcome page at the bottom like this. And of course, they also show you how you just set your environment variables like this, which is essentially what we've done already. All right, so next what we'll do is we're going to go ahead and install the SDK and do some testing to make sure things work. Let's go ahead and create a virtual environment for our project like that. Of course, if you are on Windows, that is a different command. And we have our environment, virtual environment there. Okay, next, let's go ahead and copy all of this. Create a new file here. Let's just say app.py. And let's paste all of that. Make sure that I'm running our virtual environment. So okay, so now we're going to go ahead and install Unstructured Client. Okay, very well. Okay, so now I have this data folder. I have this fake memo PDF. If you click, it's just a fake memo that we're going to be using just to test things out, to make sure things are working. And so I'm not going to use the output file here. I'm just going to use that data. So, and we go to fake memo a PDF. So that's the name of fake memo PDF. All right. So here you can see that we have client. We using the unstructured client. We pass in the API key for unstructured API key, making sure that these are actually the names that we have set up here. So let's make sure that they're the same. Yes, and unstructured API URL. And so I have our unstructured client set up. So I've modified a few things here. So we're using these operations and call the partition request, and we're passing the partition parameters here. So the files are going to be the files which we are receiving and writing in shared files, getting the content and the file name, input file path, and we're passing split PDF, and we'll make sure that the PDF is split is true, and allow fail to true, and split PDF concurrency level 15. So it doesn't matter what's going on here at this point. We just want to make sure that things are working. And of course, we are going through the document and getting all of the elements in the document and creating the actual JSON element, and we're just printing those items out here. So we just want to test to see that this is working, our setup is working. We're able to take a document, an unstructured data in this case, and work with it to remove parts of the document, right? It's a small document, but we're going to test it out. Okay, so make sure we have that .env, say load.env, and we're just going to say load env, where we have that. Let's go ahead and give it a try. Okay, so now it should be working, and you can see the partition happens. So we have preparing to split document for partition, and then the starting, allowing fail to set 1, concurrency, everything, and it's going through the process and partitioning without splitting because it's a very small file, as you see. Successfully partitioned the document, and it gives us the payload of everything. So we have type, narrative text, and we'll look into all of that. It's got that part, the narrative text, to be the May 5th, 2023, and has some metadata and everything is there. Of course, make sure that you have this working, and we have narrative text again, this payload with text to whom it may concern. So it's really working, and essentially it's splitting our very simple document here and extracting the correct information, all in the form of JSON, which we can extract and get that information. Okay, so this was just to let you know that this is working, the setup is working, and all is good. All right, so now that we have everything set up, in the next videos we are start diving deep into unstructured data, pre-processing of this data, and go from there. So now we're going to start in the process of looking how to use unstructured framework and learn how to use different tools that come with unstructured to parse or to extract data, unstructured data, in different formats. So we're going to start with PDF, and then we'll go into the HTML and then a PowerPoint. So let's look at the data here. So you can see I have all these files. By the way, you're going to have access to all this code, so don't worry too much. So we have this Microsoft OpenAI PPTX. This is the format for PowerPoint, and it's a very simple file, really. PowerPoint, it's just one slide with this information here. I found this online, and it's just this, nothing really out of this world. Okay, so I'm going to show you how to use unstructured to actually parse all of this information. And then we have this Medium blog, which is going to be just an HTML file. And then we have this mindset PDF as well, which we're going to be using. So it's just a book that I created that will allow us to extract information from. It's about growth mindset, fixed mindset when it comes to programming, and so forth. Okay, so that's what we have here, and we're going to do that. All right, so this is from previous testing that we saw. We actually used this fake memo PDF and created the unstructured client and everything to set everything up. So we should have this working, but I'm going to continue now with this process of using structured to parse different kinds of files, document types. So most of the code that we have here, we're going to use in our new project. So what I'm going to do, I'm creating this new project, new folder or directory to simplify everything. Okay, so I'm going to create a file inside of there. I'm going to call this app pdf.py. So I'm going to go ahead and borrow a few of these that we have here. In fact, I can borrow pretty much everything. Just take everything because it's PDF. So we're going to just we're just going to go ahead and take everything. So remember, we're just importing the .env because we're going to load all of the environment variables, the APIs and everything, the API keys and everything. And then we have to pass or instantiate our unstructured client here. And we need to pass the API key auth. And we're getting that from our environment variable as such. So we should have everything set up right now. If not, go back to the previous videos in this course where I showed you how to do that. And as you know, you also have to pass the server URL. And we pass it like that. And of course, we open the file as readable bytes here, and we pass the file input or input file path, which is what we have here. Now I'm going to change, instead of fake memo, I'm going to get to the mindset PDF as such. And so we have that. And of course, now what we're doing here is we're using operations. So if you go up here, you can see operation comes from models from unstructured. Okay, so operations here, we can go and get the partition request. So invoke the partition request to say we want to go ahead and take that document, we pass in the file, and we want to start doing the partition. And the beauty of the partition request here is a request because we're actually doing an HTTP request to the unstructured server, and they do all of the partitioning and everything in the backend and then return us something. And of course, there are a few things we pass here. Inside, we pass an object, which is in this case from shared partition parameters. We need to pass these partition parameters that says, okay, what are the things we're passing along to be partitioned? So we pass in the files, in this case, just one file, of course. And then we also have to pass a strategy. There are different strategies. So in this case, if you have over, we have the high res and auto, and default is auto strategy to partition this document. So we're just going to go ahead and get auto. And of course, we have to split PDF page to true. We want to be able to split that. Then we have the split PDF allow failed. If you have over, it tells you exactly what all of these means. Okay. So this was going to come in as a request. So we put that in a variable. It's going to be a request object, as you see there. And then we put inside of a try catch here because we're making a request. We never know what we're going to get. So it's always good to put it inside of a try catch. Go through our client again and go to partition, right? To actually pass the request because it needs to be passed around. And then we get all of those elements from the document and we put them as element dictionaries as such. So we loop through each piece, each partition that we get from the document. We're going to get the element of that document, right? And put that in a list, as you can see here. And that's going to be element dictionary. And of course, we want to make those into JSON format. We just say JSON dumps, pass those elements and indent to, and we can print that information. So exactly what we saw before, but now with different PDF file. Let's go ahead and save this and run real quick. Okay, so I am in my intro project folder, and then I just say Python app pdf.py, and let's go ahead and run. Right, I should have said Python 3. Let's go ahead and run. Okay, looks like we're having some issues. Okay, mindset, I made a mistake. Typos. This should be mindset, not what I've written there. So mindset. Let's try again. Okay, has to be like that because we are going outside to get to the data. All right, this time we should be able to get to what we want to get to. Let's go ahead and give a run, and voila, you can see the partition went through the process. It's still going through the process. You can see it tells us info preparing to split document for partition, starting page number set to 1, allowing failed set to 1, concurrency level 15, splitting pages 1 to 51. That's a lot of documents. So it's partitioning, it telling us set that it's doing it. And of course, you can see it sends this request. And after a few moments, you can see that we have this payload that comes in. And the beauty here is that we can start looking at all this partition, all these elements that were transformed from our unstructured document to this JSON, which is clean and structured. Data. There's a lot here. Let's go all the way so we can start looking at things here. So at the top, we can see that we have this file type, which is application PDF, and also the languages. This is in English. So it inferred all of that from the document itself. And the number of pages. So this whole document has 40 pages. The file name is mindset PDF and starts extracting things, right? So look, this is very important because we said that it's able to extract pieces from the document, right? That is the whole idea. So it says here, for each piece that is extracted, it categorizes everything. So you can see the type of this piece of data that was extracted from the document is a title. Indeed, it says text, the power of community encoding. So now each element, these are called elements, right? This object here, each element has an ID. And this will be more apparent later when we want to save things, when we want to infer things. We're much easier because we can say, look for everything that has the type, in this case, title, as its field. And it will get that. Or we can say, get me element ID with this ID, and we'll get this element ID, right? And most importantly, also has this metadata for inference. So it created the metadata, that it be said, to add more information, additional information to the large language, so that can be consumed with a large language model. That is so beautiful. And we can continue. Look at this. It went and extracted an image as well. Type is image and give it an ID. Of course, no text. Okay. And it gives us the page number where that happens, 41. And for this title, it's also page 41 and so forth. And it went ahead. We have another title element here, and it gives us the title with metadata. And then we have what we call the type narrative text. This is just the element that it knows to extract the text, right? So you can see the type is narrative text, just text section. And of course, it's an element, has an element ID, was created, and the actual text, which is this. Coding community, whether online or in person, blah, 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 and so forth. You can see we have a title, another narrative text, benefits of engaging with the community, and another narrative text here, which is a lot of text. All of this information was extracted just like that. And sometimes when it can't categorize a type of that element, it just says uncategorized text, but still it looks at it as an element. Okay, this is probably a bullet point of some sort. Okay, and the beauty here about this uncategorized, you can see also we have what we call parent ID. So what is this parent ID? Well, that means where this belongs to, because all of this is hierarchical, right? So there's a hierarchy within this document that was created from the extraction. And so each element could have a parent ID to say this belongs to this element here, and categorize belongs to this parent ID more. But I just want to show you, do a more deeper of a dive so you can see everything that is extracted. And you should by now start looking at what we just talked about, the importance of what you're seeing here. And all of that was done without us having to do anything, just calling the API, Unstructured API, passing the information, and the back end, all of that is done, and then we'll receive this payload, clean JSON, as you see here. Very good. Let's see how to extract using, in this case, Unstructured, and extract a PowerPoint file that I showed you. So I created a new file, app PPTX, and we're going to target, in this case, MSFT, OpenAI, PowerPoint. Okay. So it's very simple, really. There are two ways to do this. The first one is to continue doing what we've done, which is to first import all the things that we know how to import. We should know how to do that, of course. Just get all of that. And import the client and the partition as well, because we can use the partition. And next, I'm going to go ahead and create the input file. But before that, also, I'm going to load all of the environment variables. And let's go ahead and create a client, as we've seen before. So nothing really new here. And what I will do next is I'm going to say, and I'm going to invoke the partition, and I'm going to pass the file name that we want to get in this case, right? So the file name is going to be the input file path as such. I don't need to pass the client in this case. All right, so once I have those elements, so in this case, this partition will go and start partitioning this file, which we have here. That's really that simple. And so what I'm going to do now, I'm going to loop through and get all those elements and transform them into a dictionary. Okay, so I'm going to say element dictionary like that. And I'm going to say for each element that we get to dictionary function as such, say for in elements like this. So now we're going to loop through, and then each element that we get from these elements is going to be coming in as a list, and we're going to transform that into a dictionary. Okay, so we can work with. So now I'm going to just say print, use JSON dumps and pass the elements so we can see something nice. All right, let's go ahead and clear everything first. In this case, app PPTX.py. If all goes well, we should see it's not a very large document, but you can see that then we get a JSON. Okay, so comes in as a list, type title, ChatGPT. So essentially it's getting this, cut this and say this is indeed the title, and then it should have all of these list items. Let's see, is that true? Okay, so it has with other metadata, of course, the title type, element ID, exactly what we saw before. The text is ChatGPT, and the metadata here, category 1 def, file directory is data, and file name is that, last modified, and all of that. And if we give it file type, okay, very good. This is presentation file type, Microsoft. And then we have the list items. This is beautiful because indeed we have a list of items that this presentation, this slide has, right? This first one, second, third, fourth, let's see, about 6, I would say. Okay. And all of those are coming in as type list item, and it has a text, ChatGPT. So it extracted all that text for the first one, all of this. Very nice. Conversational, developed by, and so forth. Okay, developed by that. And then next we should see this backed by GPT-3, right? Let's go down. We can see another list. Voila. And it was able to pass in the metadata, extract all that information in that list. And all of the last one should see it's another list item, and it's GPT-4 is multimodal. Let's see, is that true? And voila, GPT-4 is multimodal, as you see here. So this was a really good example to see, to show you how indeed this works really easily. We just pass the file and then done, essentially. Now, the other way we could have done the same thing here is, if we wanted, we could also import, in this case, from the SDK, the actual namespace or module, in this case, that will do all of that easily for us. So what I mean by that is, let me go ahead and comment all of this out, including the client at this point. And what I can do is I'm going to, so I can actually import from unstructured partition and get the PPTX. So PPTX here is the partitioner for PPTX documents. That makes sense. And so we're going to import the partition PPTX, right? So if you have over, it is a function that allows us to enter the file name or pass and other metadata that we need. All right. So we can use that instead really quickly to do exactly the same thing. We have the input file, and I can just say PPTX elements, and I'm going to pass the partition, call this partition PPTX function, and pass the file name, which is this. Okay. And just like that, I can also go ahead and do what we just did earlier. Let me just copy all of these items. Actually, all of this. Comment this out to make sure that then we pass these elements as such. And voila. So the same thing we did before, and now we are going to be able, hopefully, to see something. Let's go ahead and run this. Again, the same thing should happen. So we have different ways to do the same thing by using what the SDK provides. In this case, we can just invoke the actual function from that module and do the same thing. All right, there we go. So the same thing, it does the same thing we saw before. Very good. So I'm going to leave both of them as such. This one uncommented, so you have both of them to your disposal. Now I want you to figure out how to preprocess in the HTML. So we have two ways. You can go ahead and use the client and everything as I showed you, but you can also, as I showed you, use the module, the SDK through the SDK as I showed you. Okay, so go ahead, pause this video and see how you can do that. All right, as you know, it's very simple really. So I'm going to go ahead and borrow what we had before. So in this case, so the first thing I'm going to do, let's go ahead and actually say from structured or unstructured. And I'm going to go to partition and say HTML. Voila. And I'm going to import partition HTML as such. So now that I have this function, I can use it. All right, this is number one, right? And the second way, you know how to do it. And let's go ahead and do it. So I'm going to have the input file or input path, which is going to be our medium blog HTML, which we have access to here. Okay. And then we're going to partition it, use that function. So HTML elements, I'm going to use partition, pass in the HTML input file there. And then let's go ahead and do what we did before. I'm just going to go ahead and convert them into a dictionary. And the last part is just for us to see. I'm going to go ahead and let's import JSON, of course, and say JSON dumps so we can see. So let's go ahead and let's run this app HTML. Takes a few seconds, and always wait until you see the results. Okay, so a lot of information here. Let's go all the way to the top here. So like that, just like that, we can see we have type narrative text and element ID we've seen before. The text is before we start with you will need to follow this, blah, blah, blah. We have the metadata, of course, that was extracted. We have list item. This is a type. And we have all this information that was extracted from our medium blog.html. So you can take any HTML file that you can find and use the partition HTML and get the JSON as you see here. Very good indeed. So this was an introduction to just show you how easy it is to use Unstructured to get things done. And of course, what I want you to do before you go to the next video is to find different formats, or even to go to the documentation of Unstructured. You can do this yourself and find all the types that they can process, right? And so see how you can do that. Just go and find an AMD file, for instance, or that CSV file, and just go ahead and start processing them. It's very easy. All right, I'll see you next. So we've just done a very simple hands-on where we're able to go through different kinds of documents and extract information, pre-process them. So at this point, we know that normalizing documents is very important because it allows us to have normalized data, standardized documents in this case, or content, which then can be added or pushed into a large language model. And we know that large language models love that because it brings this contextuality as well as the meaning along into the large language models. So documents, as we know, come in a variety of formats. We know PDF, Word, EPUB, Markdown, etc. So what we've done so far is we're able to transform these raw data sources, which we know come in various formats, and transform that into a common format. And this process allowed us to extract the most important pieces, elements of these documents, such as titles, narrative text, it's just the text itself, so that we can then put all of that into a JSON, because that is a format that is widely used and it's easy to read and understand, and machines also like that format. Okay, so the reason why we normalize, well, we know why we normalize. Let's look into details, the benefits of normalization, the whole process. One of the benefits of normalization is that we have what we call this uniform processing. What that means, as you know by now, is that allows all documents to be processed consistently. This is the key point, consistently. And the beauty here is that it doesn't matter what kind of document it was, what type it was as a raw source, right? So at the end, we have this uniform normalized document. It also allows us for filtering, because it allows us to remove all of these unwanted, all of these unnecessary pieces of data, metadata, sort of cleaning things up so that at the end we have a document that won't have elements such as headers or footers, etc., or the content that are not very useful for the large language model. It also allows us for chunking, right? Normalization is a process, also includes the process of chunking, because it allows us to break down those documents into smaller sections, smaller manageable sections of content that it's easier to deal with downstream. And most importantly, I would say for organizations, especially when you have a large amount of data, raw data, is that it's very cost efficient, meaning that because of the nature of this process of normalizing preprocessing data, the initial document preprocessing is what actually costs the most because it's very resource intensive. If once the documents are normalized, the other tasks that come after this normalization, the first step, they are a little bit easier and the costs are also reduced because there's no need to continue doing that initial preprocessing of the document. And gives us a lot of flexibility because now with this normalized document or documents, we can do all sort of things with the end downstream result, right? Because now we can go continue do other things because we are able to do various chunking techniques without having to reprocess the entire document again. So this is why normalization of your unstructured data, it is very important, and here are some benefits. All right, so I hope you were able to go through this mini course, and you understand now what unstructured data is and the tools you need to sort of make this data structured. That way it's easier for large language models to digest, and you are able to create agents, create RAG systems that are able to converse with your data. So it's a very important first step, the pre-processing of data before we plug into our RAG systems and so forth downstream. So if you like this content, I would appreciate if you leave a comment, tell me what you like about and what are other things you would like to learn next. And also make sure to subscribe if you haven't subscribed, and share this video with anyone else who may find this content helpful to them as they build their RAG system, as they learn about AI in general. Keep in mind that this is a mini course, which means it's part of a larger course where I go deeper into understanding unstructured data and how to pre-process unstructured data so that your large language models are able to digest this vast majority of data which is unstructured out there. Well, thank you so much for your time. Until next time, be well.